Okay, and without further ado, Daniel, I believe you have control now.
Thank you, Andres, and welcome everyone. So my name is Daniel Schur, and as Andres said, I work at KCP Technologies, and we're the sister company of Key Curriculum, and we work on the software development side of projects like Sketchpad and Fathom. So in tonight's workshop, I'm excited because we're going to be focusing on elementary algebraic reasoning. And one of the reasons I'm excited is because this topic is exactly what the focus of a project that we've been working on for the last few years. And that project, which is funded by the National Science Foundation, is called the Dynamic Number Project, where we've been looking at ways to use Sketchpad to, beginning in grade 2, look at properties of number, operation, and then as we move up the grades, elementary algebraic reasoning or early algebraic reasoning. So what I'm going to be showing you tonight are examples mostly from our project, the Dynamic Number Project, with an example or two from our curriculum modules on exploring algebra with the Geometer Sketchpad. So everything I'll be showing you tonight in this one sketch will be available to you for downloading after the webinar, so you don't have to worry about taking any notes or trying to figure out where to find the sketch. You'll get an email that will tell you where you can download it. And the webinar itself, as Andres mentioned, will be recorded so that you can watch it at a later time or recommend it to your fellow teachers who might also want to see it. So why don't we get started? So I'm Daniel, and Andres is the one who organized this particular webinar tonight, and will be taking your questions. If there are any questions that you want to direct to me as I'm doing this, Andres can take note of those, and we'll stop from time to time, and I'll answer them. And let's take a look at our agenda. So our goals for tonight, we have these 5. Our first goal is that we don't want to rush directly to the algebra. The whole idea of looking at an introduction to elementary algebraic reasoning is to be able to look at ideas from algebra in grades, well, starting in grade 3 for that matter, and gently introducing the concepts that students will develop more fully when they enter middle school. Now that said, we're going to be seeing certainly X's and Y's in what we're doing tonight. So if you're teaching middle school algebra and you want to look at some innovative ways, for instance, to factor polynomials, we're going to get to that. So this covers a broad sweep of ideas from early algebraic reasoning. Secondly, as you might expect with Sketchpad, our models are visual. There are a lot of people, when I talk to about Sketchpad, who think that Sketchpad is just about geometry. And understandably so, because when Sketchpad began 20 years ago, that was really its focus. But as Sketchpad has developed and we've become thought deeper about curriculum issues, we've realized that Sketchpad offers a host of opportunities for really everything from algebra through calculus. So this particular webinar, we're going to be looking at visual approaches to algebra that I think are pretty unique to Sketchpad and what we can do with them. And it's just this one tool, Sketchpad, that we're using. We're not relying on having to search through the web for different apps, applets that use algebraic reasoning in them. We're just using Sketchpad. Our models are game-like in structure. One thing I've found in using these models in classrooms is that students love to play games. And nowadays with things like the iPad and other kinds of gaming platforms, students expect in some ways to play games. So there are game-like elements to these sketches, as you'll see. Next, our models promote repeated use. Now with any good game, you want to play it again. You don't want to be given the same 5 problems over again. You want to receive new problems. So these models can be used repeatedly. And they also offer the opportunity for students to make games for each other, to challenge each other. Because any good game should allow you to be able to take the basic rules of the game and make your own version of it that you can then give to a partner. And finally, our models emphasize exploration and multiple solution strategies. You'll see that in the problems we give, there are multiple ways of going about figuring out the solution. And all of these different methods, when discussed in the classroom, make for a much richer experience. So those are our basic goals. And I'll get started now on a model that I'm sure is very familiar to many of you who teach algebra or early algebraic reasoning. And this is a basic balance scale model. And it's one where we have 5 different shapes. We have stars, squares, circles, hearts, and our goal, and triangles, sorry. And our goal in this case is to figure out what is the value of a triangle. So students who are exploring this can begin by taking a shape off, like maybe that triangle, and seeing that the balance no longer balances. And by thinking about the sum and having a discussion, they'll conclude that they can then take a triangle off from the other side to maintain that balance. And they can see that there are shapes that are common to both sides. So for instance, we can take off this circle and square from the left pan, and we can take the same circle and square off the right pan, and bring this back to balance. And everything that sits over here to the left of the divider is just our various shapes that we can either drag to or from the balance. They don't affect what's going on over here to the right of the divider. So just to continue, we'll take off our hearts. And okay, so now we have 4 triangles equals 2 stars. And we have our stars equal to 6. So we have this right side of the balance equal to 12. So 4 triangles equals 12. Each triangle equals 3. And we can press and check. So okay. That's a model you can, I'm sure, find elsewhere, a basic balance model. And we could create lots of problems to give students. But what makes this interesting, I think, is the fact that students can make these problems themselves. So here's a page that we call Make Your Own, and most of our models have some page that's called Make Your Own. And in this case, if I was playing this with you, I might ask all of you, everyone who's watching, to turn away, and I'll trust you do that. But of course you can watch. And what I would do when you were turned away is I might start by saying, well, what do I want my final problem here to be? Maybe I want 3 circles on this side to balance, well, maybe all 6 hearts over here. And maybe I want my circles to equal, I don't know, maybe 6 each. So I'll type 6 into this edit box here. And if those are 6, that's 6 times 3 is 18. So that means for my 6 hearts, I'm going to need each of those to be 3. Okay, so those balance. Maybe I'll drag these up just a little. So now that I have that, I need to ask myself, well, which do I want to be the unknown, the circles or the hearts? And, well, maybe I'll decide that I'm going to show the value of the circle, but I'll hide the value of the heart. And in terms of these other values, I don't really care so much about them. I might say, well, let me just drag some triangle stars over to the left side. So I drag 2. So to keep this balance, I'll drag 2 over here, and maybe just to be mean about it, I'll move 1 down here so they're not as obvious that I have 2 and 2. And I could sprinkle some other shapes onto each side. And I don't really need to see the value of the stars. I don't need to see the value of the square. I just, in fact, need to show the value of the circle. So I'll hide the triangle as well. So there I have a problem set up for a fellow classmate to solve. And the nice thing is I've made my own balance problem. I haven't relied on the teacher to give me one. And this is what I find not only motivates students, but really makes them think the most deeply about the mathematics here, is to think about what does it take to create a good puzzle? What information do we have to provide? What information do we leave out? How can we make the problem more challenging? How can we make the problem perhaps less challenging? There are times that students create problems like this where they might not even be solvable, but they still learn a lot in the process of creating them. So I'm going to stop here for a second and see if there are any questions.
The one question that came up so far is this an activity that the participants have access to?
Yes, in fact, this is an activity from our dynamic number project, and you'll receive not only the sketch with these models in them, but we'll also give you a link at the end of the webinar to our website, which contains not only the sketches that you can download, but it also has complete activity notes and worksheets. So in all of these activities, we're not just giving you a sketch and expecting you to figure out how to use it. We're giving you lots of support.
Great. That's the only
Okay,
question so far. Thanks.
great. So here is the second balance model, and this one actually comes from our Exploring Algebra with Sketchpad book, and we will provide you with the notes with this one as well. And here you'll notice, compared to the last one, it looks a little more like algebra because we have these weights with a value x. We have something kind of unique here. We have balloons with value -x, and we have weights with values 1 and 5, and balloons with values -1 and -5. And our goal is to keep both sides balanced. So for instance, if I drag 1 onto the left pan, I can drag 1 onto the right. Well, what happens if I drag -5 onto the pan over here? Notice what happened. Because it's a balloon, this one is actually pulling the pan up as compared to a weight, which would push it down. So this is our visual way of introducing negative numbers into this balance scale model. So I put -5 on the left, and how am I going to balance this? Well, one thing I could do, of course, is drag -5 onto the right. However, another way of thinking about this is, since I've dragged -5 onto the left and the scale has gone up, if I want to counterbalance that on the same side, if I drag 5 onto the left side as well, my 5 and -5 cancel each other out to be a weight of 0. So we can begin to play with this and see what keeps things balanced. For instance, if I drag an x to the right side, I could drag an x to the left, or I could drag a -x to keep both sides balanced again because we have x and -x. And we can play with this model for a while. And we can also see that if I change this value of x, right now that doesn't affect anything. My scale is still balanced regardless of the value I pick. And if we want, we can hide the value of x. So let's look at a solve for x type of problem. Here we've put some weights and balloons onto both sides of the scale, and our goal is to solve for the value of x. So I can go about the same process that we did back in the balance puzzles. In fact, I made this puzzle to be an introductory version of this balance scale here, which is a more complex version that students might see in middle school. But the same kind of techniques apply. Since I have 2 balloons, one on each side with value -1, I can drag one of each off and keep the scale balanced. I might want to hear what else could we do? Well, what if I, for instance, add 4 x's to the right side because I have 4 balloons. So if I add 4 weights of value x to one side, I will add those to the other. And not only now is my scale balanced, but I see that for each x, I have a -x. So these 4 balloons and these 4 weights actually all add up to a big weight of 0. So I can drag these and move them off of my scale entirely. And the nice thing is that for each action, if we talk about why it is we think that that action will keep both sides balanced, we can have that conversation first and then check it by doing the actual action and seeing that we don't have to wait to see what happens. We can make that prediction right away. Will our two sides of this pan balanced stay balanced? So if we continue, I see I have an x and a balloon with value minus x, so that those two cancel each other out, and we stay balanced. And we can continue this process. We can add 2 5s to the left, 2 5s to the right. So now we have 10 and minus 10. So just as before with the x's, I can drag these off without affecting the balance. So now we have 3x is equal to 9. So it looks like x is equal to 3. So straightforward for us, but quite interesting, I think, for students to be able to go through this and think about the consequences of both the balloons and the weights. And we're not going to do it here, but we could just as easily as with the previous model, we could create problems for each other just by picking a value of x, dragging weights and balloons onto the scale, and then before our partner turns around, we just hide the value of x, and we've created a problem for our partner to solve. So I'll stop here once again to see if there are any questions.
I'm not seeing any questions right now, Daniel. I think I gave
Okay.
the link to the dynamic number web project website, but
Oh, great.
just go
Thank
on.
you.
It's going great.
Okay. Excuse me. So now I'm going to show you a quote, and this is from a mathematician whose name is W.W. Sawyer, and he actually wrote an elementary curriculum called Math Workshop back, excuse me, back in the 1960s, and it was recently adapted as a new curriculum called Think Math. And W.W. Sawyer is kind of, in some ways, my hero because he's this high-end research mathematician who actually cared about teaching kids mathematics and thinking about interesting ways to do it. And this quote of his rang very true for me, that it is quite possible to use simultaneous equations as an introduction to algebra. Within a single lesson, pupils who previously did not know what x meant can come not merely to see what simultaneous equations are, but to have some competence in solving them. No rules need to be learned. The work proceeds on the basis of common sense. And this is from a book which, if you're interested, you can probably find on Amazon or eBay for about $4. So I took this challenge to heart and thought about what ways could we begin to introduce ideas like simultaneous equations to kids in either elementary or middle school in ways that wouldn't be as formal as using x's and y's, but would still convey exactly the kind of reasoning you would need to use to solve simultaneous equations. So I have several examples of that here. And this one is an example from our dynamic number project, and it's one which we interviewed a few fifth graders with a few weeks ago. And I'll talk after I show you this model about what it is they discovered. So the goal is to find the values of all 10 letters. So your first thought might be, wow, that's a lot of letters to find. Normally, if we solve for x or y, well, most that's 2. But here we need to find 10. So wow, that sounds a little bit hard to start with. And the next thing you'll notice is that these letters are scattered over the screen in a rather random pattern. And in fact, if I click Next Problem here, you'll see that each time I do, the letters dance around to new random locations. But there's also something interesting that happened here. This circle, which had kind of a beigey interior, turned green. And it turned green, and it told me that the sum of the 3 letters is 16. So what 3 letters? Let me just move this a little bit to be clear. Well, right now we have I, E, and G inside our circle. So this is telling us that the sum of I, E, and G is 16. Now we don't know anything about these values themselves. We know they're between 1 and 10, and they may be the same. 2 letters may have the same value because Sketchpad assigned them randomly. So we know that I, E, and G is 16. And if I expand my circle to make it really big, we see the sum of all 10 letters is 48. And this is actually what happened in the interview that I did, that students naturally want to make things big. So when they saw the circle and they saw that they could begin to see some of the sums, they made the circle as big as they could, and they encircled all 10 letters. So when they saw that the value of all 10 was 48, they were still a little puzzled about how they were going to figure out the individual values. And ideally, if we were doing this in a one-on-one session where I had all of you working with me, I would give you some time to think about how you might want to go about solving this, because it's an interesting question, and there are multiple ways. But what happened with this particular student when I was interviewing him was that he started to experiment. And he saw that if he made the circle a little smaller, so it encircled 9 letters, that the sum went from 48 to 41. And he had a bit of an aha moment where he realized that, well, the only difference in these two sums is that one contains the letter A and the other doesn't contain the letter A. And the difference between the two sums, 48 and 41, is 7. So A is equal to 7. And that got him pretty excited about this. And then he took that solution strategy of make the circles just smaller enough so that one fewer letter sits inside of it, and he kept applying that. So he went from, for instance, this case here with 9 letters to moving the circle so it contained 8 letters, and then used that to figure out the value of h, since we go from 41 to 35. And he continued that. He also made the circle smaller so he could move it around. So he got down to a place where he had just 3 letters, and that in our example was here. And so he then went from 3 to 2. So he figured out in this case the value of I is 16 minus 12, or 4. And he thought, okay, no problem. I'll just go from 2 to 1. So he moved this over G, and it didn't tell him the value of G. And he was pretty upset by that and thought that there was some kind of mistake. And I asked him, well, do you think I would have made this so it would tell you the value of G? I mean, if it told him the value of just a single letter, he soon realized that, well, he could just move this around from letter to letter and just figure this out. So he realized he needed to do some other reasoning about that. That if he knew the value of E and G, and he then expanded this to see the value of I plus E plus G, or in this case, G plus J, for example, he could depart just a little bit from the strategy he had been using, but still figure out the values of all 10 letters. But I thought it was really interesting that he thought he could apply this one strategy of take one letter out all the way to the limiting case where there was just one letter inside of the circle. So that's the first version of this mystery sums game. And as I said before, I'll show the answers here actually, A through J. You can play again simply by pressing new problem. So now we're going to go to the next game. And it's going to look similar, but there's going to be one big difference. And there was a big ooh and ah here when the student saw this one. Now the letters are not staying still. And that really bugged him. He couldn't figure out how this was going to work. So what he did is he expanded his circle as before, so it had all 10 letters. And he watched these letters inside, and he noticed that sometimes they don't move so predictably, like that H just jumped from the left to the right. And he tried his strategy of going down by one letter to go, instead of having 10 letters encircled, he would then go from 10 to 9. The problem was that by the time he actually figured out the value of that letter that was outside the circle, it might no longer be outside, and the whole pattern here changed. And he couldn't so easily keep eliminating just one letter at a time. The letters were moving too quickly. And in the course of this entire interview, which was only 45 minutes, he didn't come up with a strategy on this one. He felt like it was just a matter of being really quick at it and trying to figure out the values and trying to go from 10 to 9 to 8 all the way down to just 2 letters. But it would be interesting if we came back to this And if he thought about it perhaps as instead of starting big and going small, maybe this would work better for him if he started with just 2 letters, expanded that to 3, and used that to figure out, in that case, the value of B. And then he would have a number of options. He might want to drag the circle so that just the letter B and one other letter were inside the circle, and use that to figure out the value of the other letter. So this definitely added a particularly, to him, frustrating game element to it, because things move, and in a lot of games that kids play, things do move. But I thought the movement here wasn't just really a novelty to say, oh, this is a game. I thought it actually, if we had continued this interview and perhaps come back to this model over a course of several days or weeks, it would begin to have the student think about, well, you've given me this particular constraint, which is that the letters move so quickly I can't use my prior strategy. Can I adapt my strategy to figure out a different way to solve it? So once again, any questions?
Sorry, Daniel, I had to unmute myself, and I'm in the middle of writing a reply. There's a little bit of
Oh, that's okay.
confusion that and I don't know if I've made it more confusing. A couple of people are starting to feel like there's an elementary version of Sketchpad that's different from the secondary version of Sketchpad, and I keep trying to say that there's just one Sketchpad,
Mm-hmm.
but that the activities. So I'm just going to say it, I think. Yeah, Sketchpad, there's only one Sketchpad software. We have all kinds of activities and models that were built for different age groups, but they all run through Sketchpad. So, and there's also the question of which versions of Sketchpad would these work with? Do you know if these would work with Sketchpad 4?
These are just Sketchpad 5.
Yeah. Um, I'm just going to say as a general editorial comment that pretty much everything we do nowadays, we're not going to guarantee works with anything other than Sketchpad 5 because Sketchpad 4 is a decade old at this point, and it's time to upgrade. It's very old, and that's just the way it is. So you can look online about upgrade prices. You get it for about half price, um, but it's actually a relatively cheap piece of software. And Sketchpad 5 is you can download it for free trial version and check it out, but it has so many improvements over Sketchpad 4 that I really discourage anyone from trying to make things backwards compatible at this point. A lot has changed in 10 years. Um, okay, and these activities that you're showing today, Daniel, are these all from dynamic geometry? Because I think balancing with balloons is actually from the Learning Center, right?
Right. Balancing from balloons is from the Learning Center, but everything else is the dynamic number project.
Since you have your screen up, can you quickly show people how to get to the Learning Center from within Sketchpad?
Sure. So if I go to the Help menu and I choose Learning Center, this is something that actually a lot of people don't know about Sketchpad, is this fantastic resource here. And within our Learning Center, you can go through these tutorials, which have not only step-by-step instructions, but videos that you can watch. We have things like Sketchpad tips, which give you information about all the different features of Sketchpad. And we also have sample activities here where, for instance, in our middle grades, let's see, there's our balancing with balloons that Andres just mentioned, and that's available for downloading.
Great. Yeah. So when you download Sketchpad, you can go to for free to try it out. You can go to the help menu, go to the Learning Center, download the sample activities, and that's when you'll find things that were developed specifically for elementary school or for middle school or for high school, different subject areas. Um, so, and Luis just made a comment there was an earlier comment about using on the last one of the last activities you showed about using the word cancel. It was probably with the balancing with balloons. Do you have any? There was a question about do you recommend using the word cancel?
I wouldn't probably use that right away. I was probably being a little sloppy in my own language and talking about that.
Yeah, I tend to try to say that they add to zero or form
Yeah.
zeros. That's my own. personal thing. And then Luis just mentioned right now on this activity you're doing, says maybe we can make this more interesting by imposing conditions such as the product or difference of the letters instead of just having the sum.
It's very interesting you mentioned that because there are other activities we've done um, with our elementary algebraic reasoning where we've done just that. There's an activity that's in our database of activities where students are given the sum of two numbers and the product of two numbers and have to figure out what the two numbers are. And that, of course, is a preparation for having them factor quadratics to see if they can figure out the sum and the product, what information that tells them. So there are lots of variations on this. I would be very interested if you have some other ideas for ways of taking these ideas and making them into games. And I will give my email at the end of this webinar. And any ideas you have for how to either embellish what's here or to give me some new examples or ideas, very much appreciated. One comment about using Sketchpad across all these grade levels is that the fact that this is Sketchpad, and it's Sketchpad whether it's grade 2 or it's grade 12, it's particularly beneficial not just for the fact that you can use early algebraic reasoning models with it, but students will pretty soon, even if you're doing something like this, they'll come over here and when you're not looking, they'll do something like draw a polygon on their screen. And in some sense, you might say that they're off topic, and they are, but you can be using these tools to be also introducing geometry to your students when they're in elementary school and middle school. And this is the same set of tools they'll use when they get to high school if they continue through with Sketchpad. So it's one software across all grades, no need for the students to learn many different software tools. The other thing I should point out about Sketchpad 5, and this is a really small point to make, it's about this point. This point is the size here, that's what we call medium, and it's easy to drag, very nice for elementary and middle school students. If you were using the size that came with Sketchpad 4, that's what it looks like. And after you've been using the size there that's medium or even large, you don't want to go back to that small point. It really is quite tiny. So there's a very brief plug for Sketchpad 5. Okay, so let's move on. I just wanted to show you one other variation of mystery sums. There's nothing really new here mathematically, but it was an interesting idea somebody suggested to me, which made me think about a different way to show the problem. Here again, we have the letters A through J. Our goal is to figure out their values. And this time, rather than there being a circle, here we have a line. And if the line passes through two or more of these circles, it shows the sum of the letters in those circles. And I would be interested if this is at all different from the previous versions. I'm not sure it is. I think it's an interesting way of approaching the same problem using a different set of controls. Every time I press new problem, I get new random distributions of my letters and the size of the circles. So if anybody has any thoughts on that, I'd be curious. Okay, let's move on to a new activity. And this is one that I wrote about a month ago. And I really like this one. It was sort of a long time coming in figuring out how to make this work. It's called Sneaky Sums. And I almost imagine this game being played with dice. It works well with Sketchpad, but I have this image of it that you have this 4x4 grid, and you have 16 dice. And you can see different symbols on each side of each individual die. Either a triangle on one side, a square, a circle, or a hexagon. And one or two sides of each die are blank. So these squares here are just die which, when you've rolled them, are blank. And if you've ever played the game Boggle, where you have letters on the dice and you pour them into this 4x4 grid and they land, that's kind of what I'm imagining here. That this shows what happens when you've shaken some dice and they've fallen onto this 4x4 grid. Here's their pattern. And each of these shapes has a value, a numerical value, and our goal is to figure out the value of the shapes. So each time I click New Problem, I get a new random arrangement of these shapes, totally different each time. And the nice thing is we can customize this to the level of our students. So for example, here's one that looks fairly simple. We can show the sum of the symbols in any row or any column simply by pressing one of these 8 buttons along the side or along the top. So I might, for example, say, show me the sum of this row. So I see that 2 circles are equal to 2. So each circle is equal to 1. And then I might do the same with this column here and see that each triangle is equal to 7. And actually, I can just go ahead and do that now for the hexagons. And in this particular problem, well, I don't have any squares that are showing, so I can't be expected to know their values. And I can show the answer. And every time I press, I get a different problem. So here's one that looks a little more complicated. And I'm wondering if anyone in the chat panel can suggest what row or column they'd like to see. Row 1, 2, 3, or 4, or column 1, 2, 3, or 4. And if Andres, you can let me know if there are any requests, I will take them.
Oops, column 3. We've got a lot of column 3.
Column, okay.
We've got 3 requests for
12.
Column 3.
Okay.
And then we got 1 request for row 4.
Row 4, okay. Huh. So, I'm thinking there's some interesting strategy going on behind that. Does anybody want to conjecture the value of a shape at this point?
All right, got a couple people saying the circle is 8.
Circle is 8, okay.
So
let's look at this. We have the square and the triangle add up to 12. And we have the square, triangle, and circle add to 20. And this kind of reminds me of that previous problem going back to mystery sums, where we saw the value here of 2 shapes, and then we expand the circle to see the value of 3 shapes, and we see that we have an extra circle here, circle plus triangle plus square versus triangle plus square, so our circle is equal to 8. And we could continue on with this. Just for time's sake, I'm not, but you could go and figure out the value of the remaining shapes. And I also want to just quickly show you that there's another version of this sketch, a make-your-own version, where I can assign any value that I want to the shapes. If I was playing this with you, you'd look away. And then I could hide the answers. And if I really wanted to make this as customized as possible, I would decide which of these various configurations I wanted to give you if I was being nice or nasty. So this is another example of what I think that quote that I showed you earlier, where I said that students at a very young age can begin to study simultaneous equations, but do so in a way that are much more puzzle-like and game-like, where they won't even realize that that's what they're doing. So I will stop to see if there are any questions.
no questions. Somebody, Kim says this looks like a super introductory problem to get kids thinking at the beginning of the year. There was also, I think, from the same person, Kim was asking earlier about whether there was a way to learn how you could tweak these sketches to make them fit your learning objectives better. And I just replied that a lot of times these elementary sketches in particular are great for using with younger students, but they're in fact incredibly complicated constructions, and sometimes it's not that easy to figure out how they're built. But Daniel is going to show you, for those of you that want to explore on your own, You can always do a show all hidden in a sketch. You just go to display show all hidden, and then you'll see all the stuff in the background that's making it do what it does. And it can be kind of fun if you're up for the challenge to try to deduce, backwards engineer exactly what's going on and then tweak it. Yeah. And another really helpful tool for that kind of analysis, if you're really eager to see how a sketch works, I'll let Daniel explain how the information tool works.
Yeah, the information tool is a really cool tool, which I'll also say only comes with Sketchpad 5. And if any of you have done what I just did, which is to choose show all hidden, and your comment when you see that is, oh my gosh, I don't know how to make any sense of what I just saw. There was so much. This information tool can really help. So when you choose that and you click on an object in your sketch, like this show sum button, it says this button hides or shows measurement 5. So there's measurement 5, and it says this value, which is currently hidden, calculates sum plus sum plus sum plus sum. And if I click on one of those, I can keep following along, and that probably was somewhere over here, yeah. And I can begin to reconstruct what happened. Now, that doesn't always help you a lot, because you can have a very complicated sketch like this one, where it still is quite difficult. But even in cases where you're just, if your students have constructed something like equilateral triangle, and they want to be able to see how it came together, this information tool is a great way to be able to read in nice sentences how everything depends on each other and to begin to work backwards to see the dependencies. So,
Okay. I'm getting the question again about where can you find these sketches. These are available through the dynamic number project. I'll put the link up again. I've linked it a couple of times already. Um, these are not in a book. These are actually part of an ongoing project that's developing new curriculum, and these particular models are free. Sketchpad's not free, but the models and the curriculum developed around these models are free. So Daedra I'll put the link back up again. Um, and Piyush is asking how can you use Sketchpad 5 to create such activities? That's really beyond the scope of a beginning webinar on Sketchpad for elementary school. Creating these kind of sketches, if you're really interested, you should look at our online course offerings, and the most recent uh, course that we've started to offer just for the first time this week is called Constructing Dynamic Demonstrations with Sketchpad. It's considered more of an advanced level Sketchpad course, and that would be the place to, if you really want to learn how to develop models yourself, that would be a kind of a 6-week learning experience you could go through to prepare yourself for this kind of sketch building. But for right now, we're going to just focus on using these models that are already built by the Dynamic Number Project to work with elementary and middle school students on mathematics.
okay, so let's look at one more type of model tonight. And this is going to be looking at multiplication. And we're going to start with problems where they're just straight out multiplication problems. But then we're going to branch from these into multiplying binomials. So here we have a representation of 25 times 37. And if we were doing this with students, I might start with 20 times 30, and then slowly drag out here to see that we have 20 times 37, which is 20 times 30. This is the 600, composed of 600 squares, and then 20 times 7. So we see the partial products. We can then drag this point down, and now we have 25 times 37, and we see we have again the 20 times 30, the 30 times 5, the 20 times 7, and the 5 times 7. And we can show those partial products in the corners. So we have 600 for 20 times 30. We have 150 for 30 times 5. 140 for 20 times 7. And 35 for 5 times 7. And we can also, if we want, show the actual sum of those here written out. So there's a view of multiplication using partial products. But what I'd like to show now is let's look at the problem, say, how about 37 times 28? So let me just type that down here. 37 times 28. Okay. So here's one way to represent it. But we were wondering if there was another way of doing this. What if instead of representing 37 as 30 plus 7, we instead showed it as 40 minus 3, and then we showed 28 as 30 minus 2. Not something that often works too well with these models. But let's look at that. So let me start here with dragging this blue point to get 40. And let me drag this point here to get 30. Let me move these over again. And let's drag that here. So here we have 40 times 30, and that's what we see here in the familiar form of 40 times 30. And now let's look at what happens if we take 3 away from 40. So this time I'm going to drag, rather than dragging this orange point to the right, I'm going to drag it to the left. And now instead of having a positive yellow area, we're getting a negative orange area. So we see that in doing that, we've taken our 40 times 30, or 1200, and we've subtracted from that this orange strip, which is the minus 3 times 30. And you'll recognize that here from taking the minus 3 in this term times the 30 in this term. So now we have 30 times 37, but we want to see 28 times 37. So I'm going to drag this point, instead of down, I'm going to drag it up. So now look what happens. What have we taken away? Well, we have this strip here, which is a minus 2, and we have our length here of 40. But notice that there's this area here that's been taken away twice. This area that's the combination of the two oranges that's more of a deeper red or a brown. We took this away once already in this strip here, the 3 times 30 strip. But we've just taken it away again in this strip here, the minus 2 times 40. So we have to, instead of taking it away, since we've taken it away twice, we have to add it back in there once, this 2 by 3 area. And where does that come from in our traditional method of multiplying? Well, that's the minus 3 times minus 2, or positive 6. So there's a bit of reasoning to go through here with students about what's going on. But we think this visual model of looking at multiplications and partial products in the case where you're subtracting rather than just adding can give students some insight into the traditional algorithm for this. So where does this lead? Well, this is a sketch we can be using in elementary grades. Let's look at some factor games that use the same visual representation in middle school. So we're going to be choosing some quadratics to factor, and we have a choice of games, A, B, C, D, or E. And in each one of them, there are some different constraints to the values of the coefficients of A, B, and C. So here, for instance, in our simplest game, A is equal to 1, and B and C are positive. So let's look at that. So this is an actual game, and our goal is to drag these points to factor, in this case, x squared plus 7x plus 12. So let's say I get it wrong. Let's say I try x plus 4 times x plus 2. Well, I am going to check my answer. And oh, please try again. And notice that the value of the problem went from 10 to 8. So because I've checked, it's telling me that I'm only going to get 8 points if I solve it correctly this time. I could have pressed next problem instead of check answer, but if I was wrong, it would move me to the next problem, and since I was incorrect, I would get 0 points. So now if I factor this correctly so that I have x squared plus 4x plus 3x plus 12, I can check my answer, and yay, I got it correct. And I can move on to the next problem. Well done. And now I am on problem 2. My current score is 8 from the previous problem, and the value of this new problem, x squared plus 6x plus 9, is back to 10. And this will take me through 10 random problems and give me a final score at the end. And you might say the scoring element of this is really not part of being able to factor this in any way, but it does add to the appeal of the game in that students can get a score, the teacher can look at the student's score, just makes the game more fun and a little more accountable. So in game B, just to give you a sense of where this goes, here the coefficient of x squared is not 1, so we can actually have a little more of a challenge in terms of factoring this because we've got to figure out the coefficients for both the x's and for the constants here. And if I press next problem, let's just look at what some of the new problems look like. So there's a sample of them. In game C, we come back to this idea of negative area because now we can have negative coefficients for B or C. And in game D, just let's see another problem if we get anything with negatives. Okay, there we have some negatives. And in game E, just to show you where this leads, we take away the visual scaffolding, and now when you're factoring, you're just relying on dragging these pointers along the top and left sides of this grid. And if I show a hint, that shows me the partial products. And that could be very useful for some students. It'll cost them a little because the value of the problem is now 8 points, but there's lots of help that can be provided along the way. And this could be, all of these games, I think, are great things to give kids to do on their own, and maybe even don't collect the scores at first. Just give them the chance to keep playing and be motivated enough that they're going to be exploring this in the visual context where Sketchpad keeps giving them new problems. So this is also a dynamic number sketch on our dynamic number website, which we'll give you again, and we'll give you this sketch when we send you the webinar materials. So let me ask if there are any questions.
Not so much about the activities. Question about the what if you could open these on the iPad, which I answered, but maybe you want to mention briefly about the relationship between Sketchpad and Sketchpad Explorer.
Right, right. I do want to mention that, and let me go to my last page here. For those of you who don't know, we've released Sketchpad for the iPad, and it's free, available on iTunes, and it allows you to open any sketch made with Sketchpad 4, pretty much any sketch with Sketchpad 4, and any sketch with Sketchpad 5. And it won't allow you to actually build things on the iPad, but you can use models where it involves pressing a button, dragging objects, changing the value of a number. And so everything I've shown you here tonight, let me think about that for a second. Everything, yes, everything works beautifully on the iPad. In fact, if you have an iPad and would like these to be formatted just perfectly for it, the Sketch Exchange is part of key curriculum where we not only put up our own sketches where you can download them for free, but we have all of the people in the Sketchpad community, anyone who would like to, can post their own sketches for the whole community to see. And what I've done in Sketch Exchange is I've taken all the dynamic number materials which again, this is the website right here. And I've taken the models that are particularly good for the iPad, which is all the ones you've just seen, and I've formatted them so they are just perfect for the iPad screen. So if you'd like to use these on the iPad, I would encourage you to go to the Sketch Exchange site, and there's a tag there for dynamic number. And if you click on that, you'll see all the dynamic number activities. And if you download them, you'll see that the ones that are for the iPad are formatted for the iPad use. And I think these would be great to use on the iPad. So just to summarize, you'll be getting an email which will have a URL from where you can download the zip file for this webinar, which will include this sketch. The recording itself will be up soon, and you can view this webinar again or share it with fellow teachers. And here's my email. If you have any ideas for these activities, or if you're interested in testing them out and letting me know how they go with your students, I would love to know. I'm in New York. If anyone happens to be within a reasonable distance of New York and would be interested in chatting with me about this in person, coming to their school to see them use some of these activities, I'd be very interested.
So if anybody else has any other questions, thanks for the compliments that are coming in from some of you. But we do have a couple of minutes left, and this would be a good time for any other questions or clarifications. Again, all right, looks like mostly we're getting thank yous. So yeah, once again, if maybe I'll take the screen back, Daniel, I'll leave this up, but come to our website, keycurriculum.com, and from there you can download Sketchpad. You can download it for free. It will be the full-fledged software, except that you will not be able to save or print, and you'll be timed out after 20 minutes. But at least you'll have the software and you can play with it, experiment with it. You can get to the Learning Center from there and try some of the tutorials or sample activities. And you can go to the dynamic number website to download the specific sketches, the models that were presented today. Those are all free, and they all have accompanying materials, worksheets for students and so forth, teaching notes. So it's a great set of expertly built models that are specifically built for young learners to explore the mathematics that you would explore in elementary school. So a lot of number, some geometry as well.
One more, sorry, I just wanted to make one other comment about the materials, is that each model also comes with a short movie that explains how the sketch works.
Good point. So yeah, dynamic number is definitely a great resource for those of you that are, if you're teaching elementary school or even middle school, you can go there and see the very sort of cutting edge of new sketch development. Some great activities that Daniel and Scott and others have put together. So Daniel, I want to thank you for a great session and for some great information. Let's see.
Thank you, everyone. I want to also thank Scott Steckedy, who's my colleague in Dynamic Number and somebody who's worked very closely with me in developing all of these sketches.
Okay, great. And let's see. I see a question from Jennifer, which I'm just going to answer right now. There's no such thing as free Sketchpad for the desktop. There just is not. What you can do, though, is with a purchase of a license at a school, you can buy student licenses, and you can even buy 1-year student licenses that expire after 1 year, which are become a lot cheaper. But I would encourage you to go to our website and find that information there about getting the student versions of Sketchpad. Okay, great. All right. Well, thank you all for joining us this evening. It's great to have a large group join us, and it is now 5 o'clock. And so I'm going to leave the webinar open for another couple of minutes, answer any last questions. But at this point, I'm going to say good night and thanks again for attending.
Thanks, everyone.